Good morning, good afternoon, and good evening, wherever you are in the world today. My name is Paul Webb. I'm the founder of B2B Energy, and I'm also your host of Energy Speaks Back. We'd like to thank our sponsors today, B2B Energy and the Clean Energy Revolution. And if you want to know more about Clean Energy Revolution, go onto LinkedIn and type hashtag Clean Energy Revolution. Energy Speaks Back interviews energy experts from around the world. Welcome to our summer series in episode 39 of Energy Speaks Back. We would like to take this opportunity to thank our partners today, Ester Energy, and you can find out more about Ester on their website, which is esterenergy.org.uk. Weekly, I present to you experts from around the world. Today, we are in Indiana. Our purpose, as always, is to provide a good understanding of energy management knowledge from around the world, which is available today for us to deliver savings that impact on our planet. My guest this week is a specialist in modeling, simulation, and finite element analysis. A senior mechanical engineer specialist, coach, trainer, mentor, and consultant to other mechanical and structural engineers and companies. So without any further ado, I give you Dr. Khosrow, Nema, to his close colleagues. Good afternoon, Nema, and how are you today?
I'm doing great. How are you doing, Paul?
Very good, thank you. It's really great to see you. And we understand you're in Indianapolis.
Yes, I am.
Right? And tell us, make us jealous. What's the temperature like there today?
Temperature is good, a bit humid and rainy. So
right.
Definitely it is warm. Yes, it's getting warm. It's getting warm.
Good. I'm actually today with the UK has just hit 24 degrees. Maybe our summer has started, but I'm sure by next week we'll be saying it's all over.
Yeah, sure. 24C, I assume. We're talking in terms of Fahrenheit here.
Yeah, right. Okay. Well, it's great for you to join us today. I've heard lots about you from some of your colleagues in the industry. And just for the benefit of our listeners today, could you give us some background to what brought you into this industry and what you're doing?
Yeah, sure. I'm also a faculty of mechanical and energy engineering at Purdue School of Engineering in Indianapolis. So that's my world that I've been working at, and chairman of Advanced Renewable Power. Well, I've been in the industry for just about 30 years so far, and in various areas, and some government, some private, software industry as well. We had the software company, which we still have. And then 10 years ago, right about 10 years ago, more into the energy, particularly renewable energies and batteries and stuff like that. Before we started Advanced Renewable Power, I was working and consulting with another company in town, which has developed the batteries for electric buses in the United States and Europe as well, the Allison hybrid buses. Those are still shining and doing extremely well. So the reality of getting into the advanced renewable power was really, the puzzle was very, it kind of came to me, and it was very simple. If you look at this, you don't see that, you see the phone right now in my hand. Mobile phone, 50 years ago, half of the world did not have access to phone communication. And when this was invented, the mobile phone was invented, everybody in the world has right now communication. Most people in the world have communication. And the reason they didn't have it before that, because they had to wait for the landline to come to their house. And that landline, I remember myself when we were a child, we had the money to do that. But since we were outside the bound of the city, we had to wait 20 years in order to get the phone into our house. Yeah. So the same thing really is happening today and has been happening for energy, electricity. There were 1.6 billion people in the world today do not have access to electricity. Why? Because they're waiting for transmission line to come to their house, and governments cannot afford to take transmission line to their house, particularly when you go to what I call south of the world, southern hemisphere, in Africa and portion of Asia, South America. They have been waiting for 50 years to have electricity. And today, if you do not have electricity, you kind of don't live because everything is attached to electricity.
Yeah.
You don't have internet, you don't have education, you don't have the economy, the digital economy. All the above doesn't exist. You don't have the clean water. Just the living, the agriculture portion of that, the refrigeration units. There is a program we're working right now with Senegal and several other African countries. I'm told they are losing half of their food because they don't have the refrigeration system, the mobile refrigeration system, the cold chain. And when you walk back, everything you want to do, you have to have electricity. Mm-hmm. And we said, okay, well, how can we solve the problem? Well, similar to the phone lines and landlines, how can we do electricity without the transmission line, right? Yeah. Yeah. Can we eliminate the need for transmission line? That's really core of our thought process and core of our technology. And at the same time, by not needing the transmission line, how can we cut cost for them so economically is viable, rather than having 42 cents per kilowatt hour? Can we do something for 5 cents per kilowatt hour so common, ordinary people can afford it economically to have electricity? So that was the really thought process behind the renewable mobile power grid, the term we call mobile power grid, something that also it's mobile and so we take energy and electricity to them rather than trying to transmit to them. So that's really the thought process behind why we get to the industry. And then, of course, our experience in battery business. I've been in battery business over 10 years. The building batteries and the cell, all the electrochemistry, everything has to go to the batteries and the mobility. My expertise, in school, I call myself dynamist in the shock and vibration and thermal things, which are very, very essential to have the technologies that we're talking about.
So you touched on maybe some form of grid system that you're going to provide. Where are we going to source this energy from? What type of energy is being generated to start that?
Currently, there are sources of power that is integrated to our current system that we built for Indiana 5G. If you have seen some of the pictures, in fact, we put on LinkedIn just recently. We launched it at Indy 500. There are 4 sources of energy, but the terminology generally generation is in terms of power, means kilowatt. Of course, the solar, wind, existing grid, if there is any grid, and the backup generator always as the point. But frankly, the biomass or any other energies that is available, we can take it in because you look at the power. What is this? It's a current and voltage and frequency, which differentiates from our standpoint. Yeah, from a customer standpoint, they are very different. From our standpoint, scientifically, they are the same stuff. They are not different. You have 3 numbers coming to you, and I don't care where the source is coming from. But as a mobile facility with it, solar and wind, we have specialized wind turbines, which are also mobile wind turbine, you might say. It is as big as a refrigerator, basically, right? And mobile power grid is really designed for a community, right? I just want to clarify this, is it for a community system. It's not like putting a panel on somebody's house. That's not our business. Or we are trying to have a centralized power station that has 100 megawatt for a whole city of 10 million people. That's not what we do. Yes, we break a large city to a bunch of zones. We call them 1,000 homes as a zone, or a community, or a bank, or a restaurant, or a church, or a school. They're all communities. These are designed specifically to instantly, give electricity to these communities. Now, the sources of energy are the 4 that I talked to you about that we have tested with our current system. But we can add other sources in it as well. As I get a cable, 2 cables coming to me, and I don't care where it's coming from, really. It just has the current and voltage and frequency. That's all I need from it.
And you haven't mentioned batteries. I know you've been talking about batteries, but do you deploy batteries within this technology?
On the batteries, are you asking about?
In this grid that you're creating, would you use batteries as well to supplement?
Oh, sure. The mobile power grid has 4 major components, the way we classify it. One component is the power generation, which we just went over that.
Yep.
The other component is power conversion, which we use the term universal power conversion, which right now the power conversion industry, they're all, you have to have a specifically one for solar, one for wind, one for that. We're eliminating that hopefully in the very near future. So we won't be able to just grab any energy from any source and give it to any load, what we use the term load, to anybody that needs a specific ways of energy consumption or power consumption. Those are the two major areas. The third area that is we're focusing on, we call the core of our technology, the infinite grid, which is the digital grid, right? The infinite grid, the digital grid. So we have the power generation, power conversion, and then you cannot just get directly sun and just put it into the batteries. You have the power conversion. Now the concept, the batteries then is the storage area. Right now we use lithium-ion batteries, but we have our own specialized kind of batteries. And typically, so far, most batteries are designed for the cool environment, like the Northern Hemisphere, United States, for example, Europe. Temperatures are fairly, cool comparatively. When you go south of the world, when you go to Africa, the Middle East, the India, temperatures are very high. So we have to keep the batteries at a specific temperature for ideal functioning, because life of a battery is and production of the battery and functionality of batteries is very dependent on one thing, and that's temperature. Yeah. And that temperature, that's the areas that also is areas my own personal expertise, because I teach all kinds of fluid dynamics and thermal management system and stuff like that. So we have a specialized kind of batteries that we use for storage of that, the energy, in saving energy in the batteries. Yeah.
And have you got any case studies that you've developed so far for this project?
Yes, we have previously, as I said, in the past, we did some system for another company, for government, for Air Force, and for some of the cases that we have had. And we saved tremendous amount of money. Of course, even the U.S. government, we said we haven't really focused on U.S. so far because it's electrified nation. So, yeah. But there are very many cases like the bases, for example, that they need to disconnect them from the national grids, wherever we are, and other areas, embassies. We have had some examples in the past that we have done. And we do have case studies. Right now, the current system from Advanced Renewable Power is at the Indiana 5G lab. We have been testing that for the last 3 months. And it has been functioning exactly as we hoped and we expected. And we are very happy with the current system. And also is integrated with 5G because eventually, Paul, let's assume we have hopefully millions of these units across the globe, yeah. But there's no transmission line, right? So we have to somehow gather that information. So we have to gather information from all these mobile power grids. What's the status of that, and be able to do diagnostics, global diagnostic system, and repair system. And that's why we have integrated to the 5G communication network for very high-speed communication from all these devices. Amount of information coming from every mobile power grid is tremendous amount of information to every single solar panel. What's the status of that? Every single cell inside every single battery. What's the status of that? Continuously, we gather that information from all the sources of energy production, energy storage, energy conversion, as well as the load with the energy consumption. So all that data instantly is coming to that. I wish I could show you all that other stuff, but it is there. We have a bunch of pictures if you need them. So we just took it out of the Indiana 5G lab. So all these things are coming to us down the road. We do we do data mining, artificial intelligence, machine learning to understand how is the distribution of energy is working, what regions are using more, what regions are using less, how we can, manage that distribution of energy. Within a city, we are comparing it. We don't believe there is any need for, let's say, in this country, sending energy from Indianapolis to Cleveland, for example, right? Yeah. Yeah. Everybody has sun, everybody has wind, everybody has everything. So there's no need for transmission of electricity from one city to another city. Every city, we look at it as a community or a bunch of communities within the city. So,
and then each community will have their own need, wouldn't they? So they'll be different. They won't. It's not one size fit all. Basically, there's going to be all various different.
Yeah, we have various models. We have various models, not one single model. The models that we have currently, the specs that we have right now, you're talking about 20 in increments of 25 kilowatt hour, 25, 50, 100, 250 kilowatt hour, 500 kilowatt hour, and 1,000 kilowatt hour, which is a 1 megawatt hour, the biggest unit. But you can always assemble them in different configuration if you need to have a bigger system. So we have basic building blocks of these units internally, not externally. We use it the Lego blocks. So, so I don't want to use their name in this case. So that's what they can build a system based on that configuration that need for a particular community. Yes.
Right. And you've got maintenance teams and operational team to look after these technology.
Sure, definitely, yes, of course. These are not, again, I use always, it's not a coffee mug that I just send you 10 of them. We put joint ventures together. Yeah, we put joint ventures together. Most companies in Africa, South America, India, we have, we are putting joint ventures together. There is a need for technical people, technicians, have local assembly people be able to locally support it. What we have, the Infinite Grid basically is a global diagnostics. Instantly from Indianapolis, we know if something is happening with one of these units, and we can guide them through the process and say, hey, go to mobile power grid number 9 at the University of ex-University of, let's say, Addis Ababa. Go ahead, and one of the units is one of the batteries is having problem. Battery number 9 in unit number 10 is having problem. Pull it out and put a new one in it. Those are all there, but there are still technicians, people, electrical engineers or electrical technicians and mechanical technicians who have to be there in order to support them. Yes.
So not only are we providing energy into the community, we're also providing employment and sort of labor in those areas for localized individuals to jump into.
Sure. That one of the biggest things. I remember I visited with the Prime Minister of Ivory Coast, and one of the things that he told me at that time, he says, we don't want to really have you throwing something over the wall. I said, we're not planning to do that anyway. One of our goals, particularly really in Africa, since we have been very active in Africa, particularly our primary goal, another primary goal is to help them to create lots of high technology jobs. And that's why we even do the assemblies there and local support and everything, the training. My association with Purdue University also would help. We intend to bring people and train them also in the university, even if they want to get degrees in mechanical engineering and electrical engineering. We have, in our opinion, the top school in the world to do that. Mm. So it takes a lot more than just a device to give it to them. You have to have really infrastructure for support and training and all the other stuff that we are intending to do, and we have been working on it as well. And most of these things is not just overnight things. It takes a while. It takes a while to, we have been working with them almost 3 or 4 years now. Some of them are beginning, to fruition, and people start talking about it, liking it and stuff like that.
How many systems do you have in place?
Right, currently we have, under this name, the current name that we Advanced Renewable Power, our first prototype is implemented right now under testing. We are having 3 other pilot programs that we intend to start right away. There are several more units there, the implementation. We have all the work, systems are basically all ready. We just have to launch them and implement them and work with them. And all the logistics involved in sending stuff to different countries and stuff like that right now. We hope to have at least, at least dozens in this year, implementing dozens of these systems this year for the pilot program. Most of them on the contract side, there is a large need for them. The contracts are big, but we're starting very small with the pilot programs.
Right. And then how do we, what's the financial model for this? So I can guess it's significant amounts of money to set these up and put them in place to implement them. But how does it funded the back end side of it? So the users of the electricity, do they pay unit prices and things? Is there billing for that?
Yeah, the energy so far, based on our experience, there are really 2 different models. One, if they just outright, they want to buy it, right? You're a businessman, you want to buy it, say, hey, I want to provide electricity to these 4 schools. you become a energy company. That are businessmen who become energy companies and joint ventures that they do that. The other one is power purchase agreement, right? In advance, we're not doing power purchase agreement right now because we're not that large and ourselves, but there are partners who are working with us that are working on several power purchase agreements that the government will do that. We get our money, we get the product developed because we buy lots of stuff too. We don't invent every single wire and the screws and bolts. We have to buy lots of equipment ourselves. So we have to get some of the initial funding to do that. So generally in those countries would be either in the smaller communities, they have money, rather than having $1 billion, we can give them a system for $50,000. So that's doable and works. This is one model. The other one, if they're a bigger system that they need bigger fund, the government has to get involved, has to go to the power purchase agreement. Then the government, the system that existed, they can collect the money and give it to the financier. There are financiers who do this job for a living.
Right. And tell us, what sort of challenges do you have as an organization?
Oh, there are always lots of challenges. So technologically, there are lots of stuff, we make it look easy, but there are really lots of stuff that we have to, do and be careful about doing. There are all various, we have 14 patents right now. We're working on, and there's continuously we are going to go have lots of them. The InfiniGrid is not really something done in the past. We're in a way inventing the InfiniGrid, how we can manage electricity across the globe, diagnostic system, repair systems, and very many other things. And another subject that I didn't even mention at this point, we have some other set of technologies. We call them the global. You will hear about it in the future. It's called the Immersive Global University, which is really educational system. In order to do the educational system, so the local villages, they have internet and everything like that goes on top of the mobile power grid. We actually have that technology, but we needed electricity to make it happen. So, and that's really there are some of the challenges to do that, provide electricity. Then the local people, right? How we train local people, the technicians, the people, the testing equipment, the logistics of taking all the equipment there. So there are lots of challenges, sure, and we are working on every single one of them at a time.
Good. And financial challenges regarding getting investors on board to support this?
Definitely. Yes, of course. Anything new is always challenging. This is my third company. Anything new is very challenging, and in getting investors, and particularly we're not in West Coast or East Coast, California and Boston. So we are in the Midwest. It's a bit more difficult to get the investors involved. Although since we have the physical units, in the world that we are, as I'm sure you know very well, it's nothing overnight. It takes 5-6 years of research and development, or 10 years of research and development before you can have some physical model that people say, wow, it looks like, how did you do that? Yeah. So we're at that point right now. Within the last 2 or 3 months, people's reactions or investors' reactions has been really very different, because now they can feel it and touch it. Because most of those people are very smart, but they are not technical. They're not engineers, they're not scientists to understand how all the stuff, why it's taking so much work and effort to do that. So we have done that. Now people's reactions and investors' reactions are different, and hopefully becomes less challenging from now on to raise. We need minimum of $50 million to get continuous support for the logistics and commissioning and implementation of our plan. Phase one. But in the energy business, there is really no limit of how much money do we need. Yeah. We can have $5 billion tomorrow and go thousands of cities and thousands of villages at the same time.
But from the financial point of view, they're always going to be looking at their return on investment, aren't they?
Sure. Yes, there is the market based on McKinsey's information. Is not our stuff. Is about 5 trillion global market for energy needs that has to be there. There is definitely a very well-defined market. There is no question about that. And we have confidence we can produce the technology to serve that market. The challenge really, Paul, is how are we, the execution portion of the business, right? The one you just asked, the executions and financing and the training, shipping, customs. There are thousands of different challenges that you have to overcome in order to really, execution is our really main challenge, primary challenge right now, because we know we can do it. We know technologically we can do it, and there's no question about in our mind we did it and is working and has been functioning. Frankly, the first unit has been so awesome that it's beyond my imagination, because I never thought it would be end up to be this good. Right? We always hope that it's good, but it's very good. 3 months has been functioning at the 5G lab, almost zero flaw. But the market needs, everybody knows that. They're all well documented. Anybody in the energy industry, they know that there's a huge segment of the market, 1.6 billion people, they live in poverty. So that's clearly defined. Yeah. Now, how are we going to implement it? Is a joint venture better option for us? Is a PPA better option for us? Is now that units are not, $10 billion to get involved is, $50,000 or $100,000. Is that a better way of going approaching it? And we're trying to figure it out.
I wrote an article recently about the energy economy, and it is growing and growing, especially in the developing countries. We are seeing it massively grow in those areas, so we've got to keep up with that growth. And I can see your technologies, what you're bringing in, will help us go in the right direction regarding that. I can see that.
Well, that's, I think you are very right. It's going to happen. The need is there. There are so many people across the globe, because of lack of energy, lack of electricity, they live in dark ages. They live 100 years ago, 200 years ago. They have not really connected to the new world. So there is a human aspect part of the business as well. We have totally. Some investors in philanthropic people also talking to us right now, which we are very hopeful. It's a human portion of it is also extremely important to us, because getting 1.6 billion people out of poverty, that's, to me at least, that's amazing. Any investors who's talking, most investors really who are talking to us, yes, there is a return on investment, which is a tremendous market out there, but at least hopefully they want to leave a legacy.
Yes.
Hopefully they want to leave a legacy.
I can see that. Where is the technology? Is it all manufactured in Indy?
Right now in Indianapolis, that's where we are producing it and testing it, and right now. But eventually, when these are what we classified as sample build, these are we're building and testing. But for high volume production, will be in the countries that we are working with. Lots of them in African and India, and we have signed some joint ventures in South America. Primarily, they will be at least reassembled initially in those countries for testing and commission purposes. Yeah. But right now is in Indianapolis, and of course, attached to the Purdue University. My students are working on these things as well. I have lots of PhD students. I generally teach graduate school, master's and PhD students. Lots of smart people working on these things. Not just the students are making these things. I don't want to give you, we have real experienced people who do that. I just don't get the wrong idea when your students are building this. No.
There's lots of brains there. Yeah. Did you mention that you had a PhD or anything? What's your background regarding university? Have you got a PhD?
Yeah. I got my PhD from Purdue University. Yes, and I liked it so much, and I just stayed here, and I taught. I've been teaching there for also almost 23, 24 years. Yes.
Right. In the same university?
The same university. That's an awesome idea. We are actually ranked right now the second largest public university in the United States.
Right.
Ranked number 2 in the United States. So it's a very good school, very, very good school. So we have lots of resources, lots of brain power, lots of very, really smart people. Yeah. And the university has been very good.
Tell me, you did touch on the different sources. Is it 100% renewable, or is there part of it that isn't going to be renewable? You say we're going to use existing grid possibly. So is it
ideally is supposed to be 100% renewable, right? But if there is no sun for a month, we are not going to tell people, hey, sorry, we don't have the refrigeration. Food in the refrigerator should be thrown away.
Yeah.
The non-renewables are only as backup, just in case.
Well, yeah. Yeah.
Now, if you go off grid, of course, what is non-renewable is a generator. There is no other means that you have to do that. So we always provide a backup generator. Ideally, should never come out. And everything is done, by the way, by the InfiniGrid. So there's no human involvement. You don't go and turn on your backup generators or anything like that. You don't have any involvement. The system automatically activates the generators just in case there is no sun or wind.
Right.
So ideally, we design it so it's 100% renewable.
Right.
But the nature still controls, right? If there is no wind for a certain period of time or no sun, like today is all rainy, then what? We still want to provide electricity 24/7 electricity.
So you'll have your key performance indicators where you would always maintain that level, whether it be through the renewables, through the additional grid, batteries, or whatever. You would always maintain that level. That's what you're saying.
Exactly. Let me tell you another technical subject. Why saving? Another areas of saving. Today, without the renewable energy, so without the storage, without energy storage system, if you want to buy a system and have electricity, let's say you have to buy a generator at maximum, right? Let's say your peak is 100 kilowatt. Just I've used a number. Your peak is 100 kilowatt, but most of the time you're using 50 kilowatt.
Mm-hmm.
Without our system, you have to buy a generator for 100 kilowatt because you have to buy it for the peak.
Yeah.
In our system, we don't have to buy it for the peak. We buy it for the average, because the backup, the generator, the energy storage kicks in when you need the peak.
Okay.
Automatically, even at the generator alone, you cut it in half. No, while you're cutting it in half is what? Means you're also using half of the fuel consumption that you needed to have as well. So there are, even without anything else, that alone does lots of saving in the energy because we are designing for optimized consumption of electricity. You see, the InfiniGrid basically really optimizes the production of power and consumption of power at the same time in order to also cut fuel consumption. Even in that case, right? You're saying that you have backup generator and the battery itself. Let's say there is no even solar, there is no wind. Without that alone, we can cut substantially.
Yeah. Nema, my background's obviously energy management, and I do get involved with the renewable side and generation. Is there someone looking at what energy is being used? So we've got the balance of the demand side. So have you got teams of people say, well, look, we've got all these lights on, or we've got all these areas on, these air conditioning systems all running at the wrong set points. We need to trim that back just to balance it. So do you look at that side you don't just look at the supply side, you look at the demand side as well to balance it?
Definitely. Sure. Absolutely. Because even right now, when people are asking us, they want a pilot program, say, what are you going to use it for? Right. What kind of current do you need? There's 3 phases, a single phase. What's the peak? We always ask 2 questions. What's your peak power? What's your average power need? Yeah, the InfiniGrid, as I said, is manages the production and consumption. You're talking about the consumption portion of the business.
Yes.
Of course, we have to do that. And I also mentioned in my initial discussion that we gather all that data to coming to us, not just the production data or the storage data, also consumption data. Then we want to manage, see what is the best configuration for that particular, what we use the term zone or a community. So yes, definitely, that is an essential portion of the system design as well. Yes.
Yeah. For me, that's important because if we are supplying and generating energy and we're not really being conscious about how we're using that energy, we can have oversized systems. If we then start to look at that energy system and the consumption, start trimming that back, and then before we know it, we're oversized.
Our system is always, we ask the consumption and walk back.
Yeah. Good.
We look at the consumption. In fact, very many customers that we currently are talking to or working or designing a system for them, the first, like hospitals, right? The first question we ask, can you give us at least the bill, the annual bill or monthly bill for 12 months? We want to see what is the trend of using electricity, how much in a kilowatt hour per day average use, what is your peak per month. All these things are considered in the system design. Absolutely. Although we have the specific system, still is putting blocks together for them. We still that becomes so we can cover the peak, but we're not designing a system for the peak, right? If they go once a year for 1 day going to 1,000 kilowatt, we're not going to give them a system for 1,000 kilowatt, but we make arrangement that at particular moment there is arrangement so they can have that kind of energy consumption or production that they can give them, but on the whole year they don't have to pay for the maximum peak.
Right.
There is economic aspect of it too, though. To the system that continuously has a peak, so you have to pay lots of money for it. This way we can cut costs so they don't have to do that. That's what the energy storage is all about, you see. So you have those things as a backup, and you just get in, provide that extra things in that extra moment, and then the rest of the time you're just an average consumption.
Yeah. Nema, I like to put my guests on the spot. I alluded to you as we was talking just offline earlier. So is there anything that in your experience you'd like to give back to our audience today as a takeaway from your knowledge of the industry and what you feel we as energy experts need to know?
Something that the audience need to know, right?
Yeah.
Not that me need to know. You're asking the audience. Well, based on our experience, this is an area which is it's growing very fast. There are lots of needs. There are lots of people who need us. We need to roll our sleeves and help people get out of poverty and misery and providing them energy and create economy, digital economy for them. That's really the areas that I think people in our industry should take a second look at it, or people who are not in our industry as well. Investors, they can take a look at the return on investment. It's good return on investment as well, but there is a human aspect of it that we need to pay attention. It's very simple. Go to India, go to Africa, and look at people, how they live, and then it changes your picture of what God has given you, brain that is given us. We need to use it in the right way and the right directions. That's what it keeps me up, not in a good way. It gets me in the morning very early, and I'm working. Last night I was up till 1:00 in the morning. So that's really what does it for me. And of course, there are lots of cool technologies, people who are interested in science, and they are fascinated by science, very high end stuff. Tons of them are there. There's no end to it. There is no end to it. And the discovery side of the house, we have lots of stuff we can do. I am visualizing someday I have something as big as a refrigerator. It has 1 megawatt hour of energy in it. So it might be thinking crazy, but I think that's our mission.
Yeah. Nema, the industry needs people like you. It's an amazing story. I could listen to you for a long time. And I really like what you're trying to do, because you're trying to help the people that really need it. We take it for granted. I come into my office in the morning, maybe a little bit of light. I'll put my light on, just flick the switch without even thinking of it. I've got a mobile phone. This morning I woke up, hadn't charged properly. I don't think twice about plugging it into the mains without even thinking about it. And you're being very unselfish there with what you're doing to try and give that same benefit to other people. And it's very admirable. And it's been great having you on our show today. So thank you very much for coming.
Thank you very much. Thank you. It takes lots of guts, to live big salaries and go for zero for many years, very many years.
Brilliant. Well, thank you for that commitment and what you're giving back to the industry. And today, I'd like to say thank you for that on behalf of the industry. And please, you and your family, please be safe.
Thank you very much, Paul. I appreciate you inviting me. And let's roll together, okay?
Excellent. I like that. Let's roll together. Thank you very much.
Thank you. Bye.
Thank you for our special guest today. And thank you for our sponsors, B2B Energy, which can be found at b2benergy.co.uk, and Clean Energy Revolution, which can also be found either through various different social media networks. Type in hashtag Clean Energy Revolution. That leaves me with one more thing to say. Be safe.